just another case of prudent skepticism. I'm now loading things up against the hypothesis that I want to confirm. All right? And I'm loading things over here because if there's anything inferior about this, I want to pick it up faster. I want to give the Bayes method, the Bayes factor, some teeth, all right, to get off and started over here. So let's see what happens. I'm going to take you through this. This is the same data now. I don't have to go through the data part. Same data beginning with this set of priors and this structure, all right? So 05 goes to 0.143 after trial 1. Trial 2 goes 684. Trial 3, 813. Should we run another trial? Some people would say, yeah, you're not far enough along on the march, all right, to do this, so let's run a trial 4. We can go back and run a trial 4. Substantial funding. Let's suppose we got funding for 3 sites. Big, big trial. The sponsor says, I'm tired of messing around with this. We're going to get the answer, all right? So now we got 750 in a group, all right? We got p-values down now to 5 times 10 to the minus 5th. You like that? Those in genetics, that's not even small enough. All right. Got about a 10% difference. Nice Bayes factor. Now our posterior probability on the superior side is 0.99, basically. We're basically all the way down. All right. All right. So that's the big example. Now that's the contrived example. Now here's 2 real examples on how it works. So Will says, haven't you been critical of some studies by Dr. Stephen Nissen? And Maxine says, that's correct. I think his 2003 Super HDL trial exemplifies the problems I see all the time. So here's the paper from JAMA, November 2003. I always preface this, and especially when it's being videoed, okay? I was at the Cleveland Clinic. Dr. Nissen is chairman of cardiovascular medicine at Cleveland Clinic Foundation. I was at the Cleveland Clinic when this study came out. I was teaching a group from cardiology when this paper came out, and I used this example in that. So it's not like a Case Western professor's bashing. If you know the tension, let's put it this way, between the 2 institutions, you'll understand why I'm making that disclaimer. I think it's a real good study to understand some basic principles about what goes on in hypothesis testing. It was a preliminary communication. It was a small sample size, as you'll see. Dr. Nissen's question is, does super HDL reduce percent atheroma volume in patients with atherosclerosis? Very simple, straightforward hypothesis. All right? So here's a little diagram. This is a cross-section of the vessel that's occluded. All right, here's the outside of the vessel here. Here's the inside of the vessel. All right, this is the luminary where the blood flows through, lumen meaning clear or light. Here's the transducer for the intravascular ultrasound. And what you do is a very simple calculation. You do this 10 slices, and you use Simpson's rule to compute a percent atheroma volume. And so it's just dividing a denominator into a numerator. And in this case, the numbers are there. That's not really important. All right, and it's a 56% inclusion. You've all seen these, you know, he was 97% included or whatever. This is a 56% inclusion of this particular image, of this particular slice. As I said, they do 10 of these. They feed the catheter up. They do 10 in the particular area, and they get a number. All right, so what's super HDL? Super HDL is the technical name for it is recombinant ApoA1 Milano. The study name is ETC 216. There's a picture of the vial that it came in during the trial, all right? The design and measurements. Now I'm simplifying the trial, okay? This is simplified from the 2003, which was a trial that compared placebo versus 3 dosage levels. The sample sizes were very small. They never really compared the placebo versus the dosage levels. They only compared pre and post, but they lumped everything together. They lumped out the dosage levels together. And so here we go, all right? I guess it was 2 dosage levels, high and low, sorry. So here's a reduction, as you will, of the design. Sample size of 47, 11 went into placebo, 36 went into one of those doses, which they then lumped together, all right? They waited 5 weeks, they got 5 weekly doses, and they looked at the percent change in atheroma volume. So if you went from 56% down to 50%, that would be a 6% difference, okay? Straight difference as it was before. So the analysis that I did, all right, I asked Dr. Nissen for the data through email. He wrote me back within an hour. He said no problem. He would put me in touch with Kathy Wolski, a name you'll hear in a little bit. Kathy Wolski didn't write, so I wrote Dr. Nissen back. He asked me a bunch of questions. I answered like what I was going to do with this, and I answered the questions. And then he wrote back and he said he wasn't going to give me the data, okay? So I tried to get the actual data, so now what I'm doing is extrapolating off of numbers that they gave in the paper. So let's use a Welch t-test to compare two arms. On the absolute change, not the relative change, absolute change in percent atheroma volume over the 5 weeks. So it's similar to what he would have done, I think, if he had analyzed this way, but he didn't. The analysis, super HDL versus placebo. All right, sample size I've given you before. The mean difference was minus 1.2% in the hypothesized direction. The standard deviation was about 3. All right, 95% confidence interval, minus 3.5 to 1.1. T statistic, Welch T, p-value 0.28. P-value 0.28 comparing drug versus placebo. All right, again, based on table 2 of the Nissen paper. All right, so how would your new method apply here? Well, we can set up a region, all right? And so we'll set up a region, and this one looks pretty reasonable. All right, we'll set up essentially null, and we'll say that anything between 0 and minus 0.25%, a quarter of a percent change, all right, is in our essentially null region. You can pick any region you want. I picked this one for show, all right? Over there, super HDL is inferior. So no, notice I don't have any, like I did in the other example, I don't put any essentially null region over the inferior side. I just made, whatever it is. All right, super HDL clearly superior over here. We're going to put 0.95 here like we did before. We're going to put 0.01 over here, and we're going to put 0.04 over here to be very skeptical. We can do anything we want. That's what I'm doing here, all right? Very skeptical priors here. Very skeptical priors. And Will says, wasn't Dr. Nissen very skeptical about the super HDL hypothesis? And Maxine says, yeah, you must be remembering what he told the New York Times. So here's what from the New York Times of November 5th, 2003, and the week following the publication of this paper. This is the first sentence in the New York Times piece. Here's the title, Cholesterol Study Offers Hope for a Bold Therapy, written by Gina Collada, if you know who she is. She won an award a few years ago for her reporting, award by the American Statistician Association for her reporting. A small study of heart disease, studying a hypothesis so improbable, its principal investigator says he gave it a 1 in 10,000 chance of succeeding. Now, if somebody who's been thinking about this problem for a long time, this was like music to my ears. New York Times, first line of a New York Times article, and we got a Bayesian prior on a null hypothesis. All right? So here we go. Will says that seems like a prior for the superior hypothesis of 0.0001. Doesn't it? 1 in 10,000? All right? And Maxine says, yeah, but it was purely hyperbole. I'll give him the benefit of the doubt. All right? So here are our priors. And if you take the data from table 1 and you mash it through the Welch t-test, okay, you go from 0.01 to 0.015 with this data. You saw the p-value was 0.28, right? So it's, it's not going to move much. And that goes down, or actually that goes up to 0.962. And since it was on the efficacy side, the inferior side drops about half. So it makes pretty much sense, all right? So this would have put Dr. Nissen's hypothesis a tiny step forward on the march of science, right? Right? And Maxine says, exactly. A little tiny step forward from 0.01 to 0.015. What if Dr. Nissen had been much more optimistic? Okay, let's consider the following schema, which reflects what I call statistical equipoise. I want to thank you for coming. This is a real thrill. So Sunil and I did meet 16 and a half years ago, and I'm not going to go into as long as Sunil did because